So the hackathon. So everything that we've done up to this point has been very surgical, very tactical in nature. All of the parts so far, we have done series of lecture and lab, and we've looked at each one of these concepts in isolation, right? We looked at pods. We said, let's get a pod going, right? Then we looked at services and let's get a service going pointing to a pod, et cetera, right? We looked at these things and then cleaned up, looked at things and then cleaned up. But that's not what it's going to be like in the real world. In the real world, you are going to be taking a bunch of pods, right? Replica sets and deployments and a service, and you're going to have it working with other microservices. Remember, our application is now going to be broken down into a collection of microservices. Each of them lives its own life within the Kubernetes cluster. And so what I want now, we've talked about all these various concepts, pods, deployments and config maps and secrets and all this kind of stuff. I want you to have a chance to bring it all together into one big project that you can really get your hands dirty and play around with it and bang on it. Because what you're going to find here is we're going to start the hackathon. And right now, you probably feel like you have a fairly good grip on Kubernetes. And you're right, you do. But then you're going to feel like as soon as we get started, you're going to feel like, oh, I didn't understand it as well as I thought I did. So then you start the hackathon. You're going to work on it for a few hours, or later on you're going to go work on it for a few days or something like that. Hopefully, I hope you do. And then you're going to come out the other side and you're going to be like, okay, now I really do get it, because I ran into all these problems and I worked through the issues, right? And so it's going to gel the understanding of all this stuff for you. Okay, it's going to bring it all together and it's going to just hopefully crystallize in your mind. And you're going to come out the other side with the confidence to know that you actually can do it because you've done it, right? This is a real application. So first things first, you have a slide deck on your computer already. It's in the exercise files, okay? Everything you are going to need for the hackathon is already in the exercise files. In there is a directory called RV Store Hackathon. And inside of there, you're going to see there's a number of files. We're going to talk through what all these are here in a couple of minutes. But the one I want to bring your attention to right now is the slide deck that's in there. Now, there's actually a few of them. You'll notice there's a Docker RV Store Hackathon PDF and a Docker RV Store Hackathon PowerPoint. Ignore those. Those are for my Docker classes. So you don't want that one. What you want is the one that says Kubernetes RV Store Hackathon PDF. And I recommend you open up the PDF. If you open up the PowerPoint, it's going to have formatting problems and things like that because you don't have the right font on your computer. That's there for me. So open up that PDF. I, on the other hand, I'm going to open up the PowerPoint just because it's a little easier to present that way. Okay, let's see. Pull up the right file here. It's here, RV Store Hackathon. There we go. Here's the slide deck. So this has everything you need in order to complete this hackathon, okay? So before I go any further, I'm going to quickly make sure that I get this up and running. Go down here. The solution is in the documentation, or it is in the exercise files. I'm just going to go to the Minikube directory. I want you to stay out of here, by the way, during this. Okay, that's going to get it running.
I'm having problem finding the slide deck. Which directory was it in?
There's a directory. So you've got all these directories at the top level, right? Exercises, Helm, Ingress, etc. It's the one called RV Store _Hackathon. When you open that up, you're going to find the PDF in there. It's the one called Kubernetes RV Store Hackathon. Yep. Make sure you don't get the Docker one. That's going to lead you astray for sure. Did you find it okay?
I'm not seeing Hackathon.
So do you see a couple of PowerPoint files and a couple of PDFs in there? Do you see like a products.json, things like that?
I mean, at the top level,
so it's in the directory called RV Store Hackathon. Do you not have that?
Oh, sorry. Yeah, now I see it.
Okay, cool.
Thanks.
All right, yeah. So make sure you open up the one that says Kubernetes RV Store Hackathon.
Okay.
All right. So, so we've gone through all this stuff, and this is your chance to do a class project. Okay. Now, this is a mock e-commerce application that I have built for you. I have built all of the components. All of the Docker images are built. They are all tagged. They are all pushed up to an online registry. They're not on Docker Hub. They're actually out on a different one. They're on Amazon's repository. That way you don't have those rate limiting issues that a few of you ran into. So it's a mock e-commerce store. You bring up a web browser and you can see products and you can see orders and you can do various functionalities. There's just enough parts here to demonstrate what a microservices application looks like and give you a chance to get it working in Kubernetes, right? A real application, of course, would have tons of microservices, right? There's no cart API here, for example. There's no product reviews. There's none of that stuff. It's just a couple of the basics, just so that you can see the mechanics, see how all this stuff is plumbed, see how all these things are wired together, right? Just enough so that you can get a taste for it, so that when you do it for real, you're like, oh yeah, okay, I've already figured out how do I, wire up services from one to another. You can see that there's lines in here, meaning these are communications between any two components, right? So this is a diagram of what the thing looks like. Let me show you the actual application before I go any further. So I'm going to open up my browser, and I've got it running on mine on port 30,080. And this is what the actual application looks like. Let me see, it may not quite be running just yet. Let me just take a look. Kubectl, actually, let me do this. Kubectl get all, and I have this in a namespace called the RV store. And it looks like it is, oh, I actually got a configuration error. So that's just fantastic. Let me see real quick what's going on here. Not sure what's going on. Kubectl, let me describe this. This is actually kind of good, guys. This is a little bit of a live troubleshooting session. So normally when I create this, it just works. So something has gone wrong, but let's see if I can figure out what it is. So I'm going to describe this pod, and it's in the RV store namespace. And I see I have, oh, an error. Okay, I know what this is. I just need to run my kubectl apply -f dot again. It's because what happened here is that some of this stuff got created out of order. I think somebody asked a question about this a couple of days ago or yesterday about dependency between different resources. And what happened here is that I must have gotten errors, and I just didn't even bother to look at the output because I was talking. Yeah, sure enough, when I ran kubectl apply -f, I got a handful of errors. It was complaining because as it created some of these things, like my jobs.yaml, the namespace hadn't been found. So there's a little bit of a dependency issue there. The namespace was created after some of the others. So by running it again, the namespace was there. And as you can see, things are starting to run. I have a couple errors, but those are temporary. And so as I go to my browser now, if I refresh this, there we go. Now things are working. So it's just because I did it the first time. So here's the application. Clearly, it's hideous. It is not intended to look good. It's intended for learning. I've made a lot of trade-offs with this application, things that I would never do in a real production application. I have, cut certain corners. I shouldn't say cut corners. I've designed some things in a way so that you don't have to deal with it. I don't want you to get bogged down in the implementation details of this application, other than how it's implemented in Kubernetes, right? I don't want you to worry about, whether this application, has all these various properties and configurations and things like that. For example, there's hard coding in some of the places of this application. And the reason is that I want you to be able to focus on the Kubernetes stuff, not the application itself. And so the design of it is one of those. I've broken it down. You can see step 1, step 2. As I go down, you have step 3, 4, and 5. I've broken it down into steps so that you can kind of, systematically work your way through the system. So when you come here, step 1 is to set the API base URL. This has a default URL in it. You don't need to change this unless you choose to use a different port number for your API gateway, which we're going to talk about in a little bit. When we get there, I suggest you use the same port number. Otherwise, this allows you to tell the HTML or the JavaScript application a different place to get its data. So you shouldn't have to do anything with this one. Step 2 shows you the products. So this is not going to work until your product service is working correctly. If I open up Chrome DevTools and I look at the network tab, when I hit refresh, watch this. You're going to see what happens here. The application first, where my browser goes to the cluster and gets this, it gets the application, the Angular application to load into the browser. And then the application running in my browser is going to make calls to get information like to products, right? So what you see here, there's a products link. This is the browser actually calling the API and saying, give me, make a HTTP GET request to localhost 30,090/products to get back the products. And then this is where it returns back the different products and renders them on the screen, right? So here's those products and them getting rendered. It does the same thing for other components as well, okay? So if you're not comfortable with this stuff, or you're not familiar with like a JavaScript type of application, that's what's going on. My browser is actually making calls to the REST API to get the data. So this is the product data coming back. The next step is we have an auth service where we can test an auth service. There's an authorization or an authentication service in here. And this is demonstrating those JWTs that I talked about on day one. This is how we can, secure backend services in a distributed way. So I have two buttons here. This access secure endpoint actually hits the product service, and there's an endpoint in there that if a JWT is not included, and it's not a valid one, it will reject it. So if I click this button right now, I see the response back says not allowed, and invalid or missing JWT caused the service to reject the request, right? If I open up the DevTools one more time here, and I look at the network call for that, oops, too far. I click that, I see it popped up, and I got a error back. Now, if you look here in the headers, the request headers, right here, there's an authorization. You'll notice there's an authorization, but it has no data in it. Usually JWTs get put into a header called authorization. So it sent that to the service. It hit this service on the backend URL here, localhost 30,090/product/secure. And that service said, well, there wasn't a JWT, so it rejected the request. On the other hand, if I hit the login button, this is going to hit my auth service. It's going to hit a different service. It's going to hit this localhost 30,090/auth/login, and that is going to respond back with an access token. You can see it right here. This is a JSON web token. So the browser is going to store it in memory. Now, the next time I hit access secure endpoint like this, you notice this time I get a response that says it's allowed, and it gives me the contents. And if I look at that one, I can see if I look at the headers, this time the request headers includes the authorization token. So the service behind the scenes gets that out of the header, runs it through a verification algorithm, looks to see is it expired, does it was it by my own private service, because it uses a secret key to essentially decrypt it, or at least see if it was digitally signed by my own service. Everything's good, and it displays me. So this button will not work correctly until you have the auth service up and running. And then the fourth step is a search service. So you're going to see we have an Elasticsearch database here. It's full of product information. And this isn't going to work until two things are working. Well, first, three things really. Your product service, which owns all of the product data, needs to be working. And your Elasticsearch service needs to be working properly. And there's a synchronization service. There is a service which periodically grabs the products from the product service and takes them and pushes them into Elasticsearch. Okay. And don't worry if that doesn't make sense just yet. We're going to look at the diagram in a minute. So if that's working, I should be able to put a term in here like hose, right? I get two products here, stinky, slinky sewer hose and heated freshwater hose. The word hose is in both of those. So if I search for hose, I should get these two products. So let's just see what happens. Hopefully it's working. Yeah, there we go. Hose brings back those two products. So that's all there is to that service. It's just the ability to bring back some. And then finally, we have orders. You'll notice here, we have orders showing up in here. They are only going to show up, and these automatically refresh. So this screen refreshes the orders, once a minute or something like that, or you can actually tell it how frequently to do. But It just periodically checks, hits the orders API, and says, give me all the orders in the system. And these will show up provided that your order service is actually working and you have an order simulator that's working, that once a minute it just generates a fake order. So you can see these are all kind of random in nature. They all have a unique ID. You can see the date that they were created. They all come from John Smith, and then they have random numbers of products. And so this order simulator just hits the service, says, give me the products, grabs a few at random, you know, calculates a subtotal and tax and a total and sends it back to the system. So it's simulating having real users on our site, even if we don't actually have them. So it'll just continually do that. Now at the top of this screen, there's a button called expand instructions. If you click that, you're going to get your a description of the application, your goals for this hackathon, which are also in the slide deck, and an architecture diagram. Okay, an architecture diagram. This shows all the moving parts. So let's just break these down. Now that you've seen the screen, let's see what we've got. This is your browser. When you put that localhost port 30,008 in your browser, it's going to hit the cluster and it's going to hit the service for the UI, and it's going to send back. This is actually an Nginx web server with an Angular application written in there. Okay, if you're not familiar with Angular, it's a Google open source project. It's a framework for building JavaScript single page applications. So all the information, all the JavaScript and HTML and CSS gets loaded into your browser, and then JavaScript runs the whole thing from there. So from there, all the calls to the backend API are coming directly from the browser. Okay, so all the calls are going to go to an API gateway. Now, I may have mentioned this during the class, but there's a number of ways that we can do this. An API gateway is a way to centralize our microservices, right? Remember, we're breaking down our system into a bunch of different microservices. Each one of those lives on its own endpoint because they're independent applications. Now, what you don't want to do is say, you know, publish to your users, say, hey, we've got an API out there, and this is what you're going to use to communicate with our systems and get information. We want you to go to, api.company.com, port 7000, and that's going to be product information. And then api.company.com/8000 is product information, is order information. Like you give them all these endpoints. You say, here's our documentation with all the various endpoints with their addresses, and send traffic to those for the different stuff. That's probably not what you want. Instead, what you want to do is you want to say, hey, I've got api.company.com. Everything lives there. It's the single entry point. And then from there, there's like different paths in the URL, /product/this. That's going to get you product information, things like that. So this is what an API gateway does. An API gateway gives us a central funnel, if you will, for all of our traffic goes through it. And then what it does is it provides capabilities to redirect traffic based on where it's supposed to go. So for example, it can look at the URL that was requested and say, well, this is supposed to be product service traffic, so let's forward to the product service. Or it's order traffic, let's go there. Now they have all kinds of other features as well. They can do things like unpacking a JWT at this layer. They can do rate limiting, things like that. Tons and tons of things go into these. They can log requests. There's a bunch of stuff that we can do with these API gateways. And there's also a number of different ways to do this. You can build your own application, which is what I have here. You can use an Nginx, or excuse me, an Ingress, which is a concept within Kubernetes to do this the Kubernetes way. There's also other services out there. There's load balancers that will do this, like application load balancer in AWS can do this traffic routing type stuff. You can use fully hosted, fully managed API management services like Amazon's API gateway. That's what this does. Requests come in and it routes the request to different locations based on where it's supposed to go, right? Now, in this case, I have chosen to simplify things for you, and it's all contained in a pod. And I'm using a framework called KrakenD. KrakenD is a project, it's an open source project owned by the Cloud Native Compute Foundation, which is the foundation that also owns Kubernetes. And so there's others as well, Apogee, Kong, there's other ones out there that will do the same thing. I've been using KrakenD quite a bit lately, and I actually really like it. It's really, really fast, and you just configure it with a JSON file. So you have in there that rules defined that say, well, when a request comes in and the URL includes, slash products, for example, just forward to a service with a particular name. And so that's all this is doing. It's just dispatching requests when they come in to where they're supposed to go. So when it sees that the URL coming in is slash products slash underscore search, it forwards to the Elasticsearch service. When it sees slash products, it goes to the product service. When it sees orders, it goes to the order service. When it sees slash auth, it goes to the auth service, right? Each one of these just has a different responsibility in the application: search, products, orders, and authentication information. Now, the order API saves its data in a Mongo database. So there's a separate service in there for Mongo. The order simulator, this is just a process that runs on a time basis. It hits the API gateway here, says, give me all of the products in the system. The API gateway returns that to the order simulator, which then forms up a fake order, sends that back to the API gateway at slash orders, which sends it to the order API to save it in the database. And then the last piece is the product sync service. It has a two-step process. It's a very simple Python script. It just gets all the products from the product API, gets them out, and then saves them to Elasticsearch. That's it. So it's an HTTP get from the product API and then an HTTP post to the Elasticsearch. That's all it does. It just keeps the Elasticsearch database in sync with what's in the product API. This is a common pattern you see with microservices where we have our data segmented. And sometimes we need to get data from one system to another so we can introduce another microservice to keep them in sync. And there's a variety of ways to do this. You can do it on a time basis like this. It can be an event base where the product API triggers an event to say, hey, there's a new product, and then it's going to flow. A bunch of different ways to do this. This is just the way I did it here to make it simple. Okay, so the diagram is in the slide deck as well as in the application itself. So let me go back to a little more overview stuff before we talk about each one of these pieces, right? So it's this mock e-commerce application. Your job is to get this. The solution, by the way, is in the Minikube directory. I want you to stay out of here. Don't go in here. Okay, when you look at the exercise files, there's a directory called Minikube. Contains a bunch of YAML files. This is the solution. I don't want you to look in here. Okay, don't look in here until later when you're comparing what you've done to the solution to see if what you've done is correct. Now, of course, this is not the only way to do it, right? You could do things a little bit differently, but it is in here, and we will talk about the solution when we're all done. There's also for you here, if you're curious, you don't need this for the hackathon, but if you're curious, in the microservices directory is all of the code for all of the applications. It's 100% open source for you. So for example, if you go to the auth API, you'll see the Golang code that is the authentication application. If you go to the gateway service, you'll see the Kraken-D configuration. If you go to the order API, you'll see that this one is a Java application written in the Spring Boot framework. So you can see, here's the Java file for an order and a repository and all that kind of good stuff, right? They're all written in different languages, just to illustrate that microservices can be any language. Other stuff's in there too, by the way. The Docker file for each one of these is in there. There's a make file, which has some handy targets to show you what commands were run to do different parts of it. So I'm actually showing you the complete life cycle here of code to how that code gets packaged, to how it gets built into a Docker image, to how it gets pushed to the registry. So you have the full end-to-end view here of everything if you want to look at it. So kind of to the point that somebody brought up about reference architectures. Yes, this isn't production ready code or anything like that, but you can see here the end-to-end plumbing on how all this works. Okay, so here's your goals, guys. I'm playing the role of the developer here. I've developed the application, I've packaged the code, I've packaged it into Docker images, and I have pushed them up to a registry. I'm coming to you for help because you are my Kubernetes expert. I'm saying, hey, I knew how to build the application. I don't know how to do Kubernetes. That's for you to help with, okay? So here are your goals, and these are kind of in the order of importance here. The first one is the big one, and this is probably as far as you guys are going to get in this particular class, just based on the time we have left. And that's just to get the application running, right? Just get all the functionality running. That's it. From there, once you have it running, I want to make sure that you have a chance to play with certain areas. I want you to make sure that you use config maps to provide environment variables. You're going to see there's a handful of environment variables in here. I want you to make sure that those are being added from config maps, not hard coded directly into your pods. Okay. You're also, by the way, going to use it to inject product data. When we get to the product database or the product service, you're going to see you have to use a config map to get this to work. I want you to make sure that only publicly accessible services are accessible outside of the cluster. If you look at the diagram here, you will notice that there are only 2 lines from the browser to the service, right? In other words, you should not be able to put in a product search service URL and get to it directly from your browser. You should only be able to get traffic to the UI and to the gateway. All the others should be private. In other words, these should all be cluster IP services when you're done. Okay. But you can have them publicly accessible while you're working through things. Remember, I showed you how to port forward. I showed you how to add services and make them node port. If you need to do that to test, that's fine. Because sometimes you're going to want to hit some of these services directly. For example, let's say you're getting the auth API working. You're going to want to be able to hit it directly just to eliminate the gateway, to get it out of the way, right? That way, you know, once you do add the API gateway, that if something's not working, it's something either the API gateway is not working or the connection between the two is not working, not, well, which one is it? The auth or the gateway or the connection, right? It's just a matter. Part of this lab is learning how to systematically work your way through this stuff and build iteratively on this stuff. Okay, and then a fourth goal is to make the application fault tolerant and resilient to failure. What I mean is you need to have redundancy. You need multiple replicas of your pods so that they can be deleted and then automatically be created, right? So you should be using one of those resources in Kubernetes that is resilient, that automatically recreates pods for you. Also try setting up probes, right? Set up some probes so that you, if one of those applications fails to work correctly, that it will clean it up and fix it, or at least take it out of service, right? You have liveness probes and readiness probes and startup probes to use. Your fifth goal, which is kind of an optional one here, if you want to go for it, is the Mongo database being a database. Try setting up a volume mapping to your hard drive. Remember the host path and the local um, volume types. You can go out on the documentation, experiment with those a little bit. See if you can get that Mongo database to save its data to a location on your machine so that if you delete the Mongo pod, the data will stay there. You won't lose your orders. Okay. And then the sixth one, don't worry about. We did not do the horizontal pod autoscaler in this class. That one has quite a bit of setup that goes along with it. Now, I want to give you a little bit of philosophy here. Like I said, everything so far has been pretty simple and superficial, and I've done this by design. As we worked through the concepts, I didn't want to push you out of your comfort zone too much. But this hackathon is where that changes. I want to push you out of your comfort zone and make you uncomfortable. I'm doing this on purpose, okay? I like to tell people the struggles where the learning is and think through your career, right? Over the course of your career, you've probably had problems that were very difficult to solve, right? You just had this problem that you couldn't crack, and you spent days on it, and you banged your head against the wall, and you did a million experiments to figure out what was wrong with it, but you just couldn't quite crack it. But eventually, something happened. Something clicked, or you had an idea in the shower, and then you went and tried it, and it worked. Something you eventually got past that problem, and as soon as you did, everything crystallized. All those experiments that you had been doing for a couple of days, all these things that you thought you understood about the problem, turns out you were completely wrong. And all of a sudden, you have this world of understanding, right? You're enlightened now about this. And you are going to retain that information because it was so painful to acquire. This is just human psychology. When something's really painful, we remember it. This is what the whole pain system's about, right? Pain makes it so that we learn lessons. When you burn your hand, it's painful. You know not to touch hot things, right? You never forget that lesson. Same thing here. So I'm trying to piggyback off of this. I'm trying to hack your brain just a little bit. I have deliberately made this hackathon difficult because I want you to go through the pain and have to troubleshoot, and I want to force you to do a bunch of experiments and fool around and tweak things and fiddle with knobs so that when you do get it, all that understanding just comes flooding in, and okay, now you're in good shape. Okay. So, it's going to be kind of painful. You might actually not like this hackathon. You're going to be like, oh, this kind of sucks. I don't like this. But then when you get it working, all of a sudden that perspective is probably going to change. You can say, "Oh, this was fun." Like, "Oh, I got this now," right? It's a challenge. That's why we play video games, because it's challenging. If things were easy, it wouldn't be much fun. So keep that in mind when you're doing this. Give this your best effort, because your efforts will be rewarded. And past classes have now overwhelmingly told me, I've run this easily with 2,000 students over the last few years. And I overwhelmingly hear the same response. They say, "Man, that was the best part of the class, because I got the most." First of all, it was fun because it was hands-on, but you come away from this with the solid foundation for Kubernetes and confidence that you can do it in the real world after that. So this is my philosophy behind this. If you're thinking to yourself, "Why didn't Tim just give me the answers?" This is why. Okay. Now some helpful hints, a little bit of tips. Okay. Start out simple. You're all going to do the same thing. We're going to say, okay, go for it. And you're all going to sit there for a minute and go, okay, where do I start? Like, what do I do? Right? Well, how do you eat an elephant? Of course, one bite at a time. Start as simple as possible. Try to eliminate anything that's going to muddy up what you're doing. Right? Pick a service. Start there. Get one service running. Implement it. Get the pods. Get the service. Get it in your browser. It's going to be broken. It's not going to work correctly, but at least you've got something running. Right? Don't sit down. I see this every once in a while. I will, about once a month, I get a student who does this, and I really recommend you heed my advice here. I get a student who sits down at an editor and writes a whole bunch of YAML files. They code out all their deployments and config maps and services, and they do all that stuff. And then they just apply it to their cluster. And of course, what happens? Nothing works, right? Nothing works. And now they have to debug all of this stuff. And the problem is they've created so many resources that it slows them down, it bogs them down. They don't just have a couple of pods and a service that they're looking at to try and figure out what's going on. No, they're muddied by all this other stuff. Don't do that. Be the person who says, right, I'm going to get some pods running. Once I've got those running, let me throw a service on top of them. Now let me try it in a browser. Hey, look, it works. And if it doesn't, at least you only have a couple of pods, or one pod, really, one pod and a service to look at, right? So start small and just iteratively work. The other thing too, by the way, is when you do that, you will have one reference that you can refer to. You will have a pod or deployment and a service that you can work from that works. Now you can copy it, paste it to the next service, make the changes, and now it's going to work, or at least you got all the moving parts right on the first one. And so, it's just going to make your life a little bit easier.
So Tim,
Also,
what's your suggestion? Where to start? Which one is that service where we
my
can start?
suggestion is to start, and I have it right here. I forgot to mention it. My suggestion is to start with the UI, because the UI is the simplest service in the whole thing. There's no environment variables, there's no config maps. All you need is a running pod and a running service. Once you've got that, then you can build from there. The auth service is another one that's very, very simple. So if you want to try that when you get to the API, you can do that one. That one's super simple. But save things like fault tolerance for later, right? Have your deployments use one copy, right? Because if you have two copies, you're trying to look at logs, things like that. You've got to figure out which pod do I look at. It's much easier to just say, well, here, it's one pod. I know which one I can look at the logs. Also, don't use probes. I mentioned this when we talked about probes yesterday. When you add a probe, if the probe itself is misconfigured, it will act like your application is broken, and it will make you think your application is broken, even if it's working. So get your application working, then add probes. There's a reason I put probes as like the fourth or fifth goal. I want you to get the app working first. Okay. And then don't forget, right? You can test your services directly when you're getting them working. You can hit them directly by using a node port service or using port forwarding with kubectl. Okay. Now the rest of this slide deck is just details. Yeah, was there a question?
Yeah, a quick question. So when you're starting from scratch like this, do you typically start with like a pod resource? and then move it into a deployment or replica set, or do you just go straight for the deployment, like right off
I
the
would
bat?
go straight to a deployment. Get yourself into the habit of just using deployments and not using pods or replica sets. You might as well just go straight to a deployment because it
Okay.
has all the benefits of a pod and a replica set built in, and it's really not that much more complicated to create than a pod. Plus,
And
you
just
already have the
just
references.
set replicas to 1 or something at
One.
first, right?
Yep. Exactly. Yeah, exactly. And that's a general rule in general for Kubernetes. Anytime, even if you just need one copy of something, still use a deployment, because that way, if something happens to that pod, it'll be replaced. And also it gives you the ability to roll out changes to it. So just get into the habit of using deployments pretty much all the time, right? All right, let me just check the chat here. Okay, yep. No, there's not a database for the products. You're going to see where those come from in a minute. Okay, so the rest of these slides are just details about each specific application in here, each specific microservice. So it's just a bunch of details. I'm going to run through them real quick, but for the most part, I'm going to let you just reference this as you go, because of course you have this slide deck. Okay, let's talk about the UI application. So this is what runs in your browser. This is in Angular, which doesn't really matter. It's just there to demonstrate to you that it's written in Angular. This pod listens on port number 80. This one should be publicly accessible. I'm letting you know that this one should be a node port service. The Docker images in here, all of these images are out on Amazon's Elastic Container Registry. That's what ECR is, and they have a public version. Back in November, when Docker implemented those rate limits, Amazon responded by saying, hey, those guys are doing rate limiting. If you really want to have a public image, tell you what, we'll host one. And so they very quickly launched a public version of it. So you don't have to be authenticated or anything like that to get any of these images. They're just out there for you to use. And latest is the tag that you can use. So I don't have any of the tags on here. So it's just public.ecr.aws/verjob/rvstoreui:\latest, which you can either put on there or leave it out. The UI needs no environment variables. I have a little information here about how it gets its data by making HTTP calls to the backend gateway. You'll also see this information in the UI when you get it working, right? If I collapse this, you can actually see right here, here's the addresses that it uses to hit those 4 backend services. And then also another mention that in the UI here, there is a text box. So when you get to the gateway service, that's this Kraken D service. If you choose a node port other than 30,090, then you will just need to make sure that anytime you reload this page, you just need to change this to whatever port number you chose and then hit update. Also, if you're running on Minikube, I know there's at least one person on Minikube here. When you bring up this page, you'll need to change localhost to whatever the IP address of your Minikube is. So anytime you refresh, because it just stays in memory, you'll have to do that. You just hit update. Like if I change this to, 192.168.1.1 or something like that, and I hit enter, you'll see it didn't refresh anything, but it's now making all of its calls to this address instead. But when you hit refresh, you'll notice it goes back to localhost. So for most of you, this isn't going to be an issue. You don't need to worry about that. For the product API, okay, this one's written in Go, serves up just the product information. A request comes in for products, it sends back a list of the products. Serves on port 9001, should only be accessible inside the cluster once you're done. The only way traffic should be able to get to the product service is through the gateway service, okay? The Docker images here. Now there's a couple of things you need to set up on this one. This one's going to give you a chance to play with config maps a little bit. The data, the product data, is actually put onto the file system of the pod or of the container as a JSON file. Okay, now this is where you wouldn't normally do this with a real product application, right? You'd actually have a database for this. But, I told you I made certain trade-offs here for this hackathon. I want you to have a chance to play around with config maps. So there's 2 things you need to do here. First, you need to inject a file. We did this with the config maps. You may remember we injected HTML files into the Nginx container and had it serve those. This is the same thing, but instead of HTML, we're injecting a JSON file that has product data in it. So you're going to basically you're going to create a config map. That config map is going to have your product's JSON data in it, and then you're going to mount that to the pod, you're going to do a volume mount into the container at a particular file system location, and it's your choice. I suggest you use the directory /data/products, just because that directory already exists. You're not going to run into any, directory, does it exist errors or anything like that. So you're going to make it so that now it's available on the file system. Now, to get the file, it's in the exercise files. It's in that RV Store Hackathon directory. It's in the same directory that the PowerPoint was on. There's a file right here, products.json. So you're going to grab that content and you're going to put it into your config map. And then when you mount that config map to your container, then it's going to create a file for you dynamically, just like we did before, that has it on the file system. Okay. So this application, what it does is when a request comes in, and this actually brings me to the second thing you need to set up. You need to set up an environment variable called product file location. And that tells the application where to find the file on the file system. So again, I suggest you use /data/products. So what the code does is when a request comes in, it looks for an environment variable called product file location. In fact, here, let me just kind of bring up the code so you can see it. That might demonstrate it better. So here's the product API. Here is my main.go. And right here, there's a function called read products file from config map. So when a request comes in, it gets an environment variable called product file location. And then what it does is it actually reads from the file system that directory plus /products.json. So it just reads it from the file system, and then it just turns around and sends that back to the user. That's all that is. So you need to give it the file and where the file lives. That's why you got to set up these two things. Okay. And then once again, this one, you can test the products directly at this URL with a port forward or a node port service or whatever. So if you were to put in, let's say, for example, you open up and you forward a port and you forward 8,000, something like that, or let's say you use 9,001, which is the number that it works on. You can put in your browser http://localhost:9,001/products. As long as you port forwarded on that, that is going to send your traffic directly to that pod and allow you to test it. You should get back some JSON in your browser that has products. That's how you can verify that this application is working without running through the gateway service and things like that. Does that make sense? Any questions about that? This one can be a little bit confusing until you get your hands dirty in it. Okay. Few more minutes. The authentication API, this one's also in Go. Super simple. All it does is there's a login endpoint, and you don't have to give it a username and password. As soon as you hit it, it just returns you a JWT every time, right? Listens on 9003, only accessible inside of the cluster. The Docker image is here, and here's the URL to test it. Really simple. There's no environment variables, no injecting files or anything like that. This one's super, super simple. The order API. Yeah, go ahead.
About the port forwarding. So those, as I remember when you demonstrated them before, they're sort of like, temporary for like the duration of the port forward command. Is that right?
That's right.
So can you port forward like multiple ports at a time, or is it like a one at a time type of thing?
Only one at a time. You would need to just open up multiple terminals to do that if you wanted to, but you could.
Gotcha.
Yeah, absolutely.
And then is there a way to query Kubernetes to see what ports are currently forwarding so you don't forget to like turn them off or whatever?
No, because the forwarding is actually taking place on the client. It's taking place on your computer because kubectl is what's doing it. So Kubernetes doesn't even know about it. Yeah.
Okay. So if you forgot, it would just stay up until you close that terminal or something.
Yep, exactly. Until you kill it. Yeah.
Well, thanks.
Sure. All right. So the order API, this one's not written in Go. It's written in Java using the Spring Boot framework. And this one does two things. It receives an order and saves it to the database, or when requested, it sends back all of the orders in the system. Okay, just does those two things. Serves on 9002, should only be accessible inside of the cluster. And now here's a very important point here, a very important hint here, and I have a couple more of these as well later on. It communicates with the Mongo service by the name rvstore-orders-mongodb. So that name is actually hard-coded into the service, okay? This is one of those examples where I'm making certain trade-offs, right? I wouldn't hard code something in an application. I would make it configurable with environment variables and things like that. But in this example, it's hard coded because I'm trying to drive home a lesson here, and that is you need to make sure things are named correctly. So that's all I'm going to tell you about that one. You're going to trip on this one, and that's okay. I want you to trip and fall on this one because there's some lessons in there. The Docker image is in here, and there's an environment variable needed for this one. The name is Spring Profiles Active, and the value is composed. Use this name and this value. This just tells the Spring application that is running within a containerized environment, changes how it communicates with other services. And then the URL's down there. The order simulator, another Java Spring Boot application. This one is a short-lived process. It runs and submits a random order to the API and then ends. Okay, so this one doesn't have a port number. It's not a web application. It's not going to listen on a port number. And it communicates with the gateway service using this name, rvstore-api-gateway:9000. Again, hard-coded into the application. Now, I want to give you a chance to play with these jobs. So create this one as a cron job, right? Running once a minute, whatever you want. You only need one, and once a minute, it just creates the container, or it creates the pod, which creates a container, submits an order, and then ends. And then a minute later, it does it again. A minute later, it does it again, okay? The image is there, and there are two environment variables needed for this one. Spring Profiles Active equals compose, and job equals true. Use these names and these values. That will make it work correctly. If you forget these, it won't work correctly and you won't get any orders. The Elasticsearch, I'm actually just using the stock Elasticsearch right off of Docker Hub. This is not an application that I built. I'm using the off-the-shelf one. This just stores products and makes them searchable. You don't need to be an Elasticsearch expert or anything like that. Of course, this one gets its data from that product sync service. It listens on port 9200. You can either run it as a deployment with a single copy or as a stateful set. If you want to try out stateful sets, you can do that just with a single replica. The Docker image is here. You can either use Elasticsearch 7.12.0 from Docker Hub, or because of the rate limiting issues, I've also put it onto my own registry as well. And then there's a host of environment variables that you need here. Use these names and these values. This does things like tell it as running as a single node cluster, and it reduces the amount of memory it needs and things like that. Elasticsearch is kind of a memory pig. So this tells it, hey, just strip yourself down and be a really lean Elasticsearch. The gateway, this is that Kraken D service from the Cloud Native Compute Foundation. Again, this is that traffic cop, runs on port 9000. It runs very fast. It's very, very high performance. This one needs to be publicly accessible, right? This is the central endpoint. This is the single endpoint to your API. So of course, it needs to be a node port. And it communicates with the other services using these names. So when it forwards to the auth service, it forwards to this address, right? So this is another important hint that I'm giving you. And then the Docker images here as well. The product sync application is a Python application. I shouldn't even call it an application. It's about a 30-line long Python script. All it does is calls the product service, grabs the products, and then runs through them and loops through them and pushes them to Elasticsearch and then ends. That's it. There's no port numbers because it's not a web service. It's a worker process. You can run it as a cron job, just like before. And I've given you the names here that it uses to communicate with the product API and the Elasticsearch. So this is that important point again. The Docker image is there, and it does have an environment variable, job equals true. So make sure you put that in there. And then finally, I think this is the last piece, the Mongo database. Again, I'm using the stock off-the-shelf Mongo from Docker Hub. I've put it out on my own ECR registry for you. It runs on port number 27017. You can run it as a stateful set with a single replica. This one should be accessible only inside of the cluster, right? And if you choose to mess with the volumes and persist that to your machine, you'll just need to know that it stores this data internally to the container at this directory /data/db. So that's what you would mount to your volume. And then it needs these two environment variables. You must use these names and values. Mongo initdb root username and password with the values of Mongo admin and secret. You have to use these usernames. This is what tells Mongo to listen for connections on those. And I've actually hard-coded those into the order API application. It will use in the connection string Mongo admin and secret, which again, you would never do in a real application. Instead, I would get those from a secret or a vault or something like that, and make it configurable, right? But I've chosen to simplify things here for the purposes of learning. Okay, so at this point, pretty much let's talk through the solution. Well, if you look at the exercise files, everything is in the Minikube directory. I originally did this when I was using Minikube back before there was such a thing as Docker Desktop with Kubernetes. So everything's in here. Now, the first thing I want to point out is that these files are organized a certain way, and there's no rules here. There's no there are some conventions and some common patterns, but there's no rule that says you have to organize things a certain way. There's nothing that stops you from putting every single resource in a different file. But there are some general things that you oftentimes see from people, and that is that they'll organize their files either, I like to call it horizontally or vertically, right? So horizontal would be, let's put all of the deployments together in one file, right? Let's put our auth deployment, our product deployment, our order deployment, etc., all in one file. And sometimes people will lump those things into what we call a workloads file. The general term for any resource that creates a pod is called a workload. And so you see I've done that here. I have a workloads.yaml, and it is full of deployments. By the way, feel free to follow along on the files on your own machine if you want. It's full of deployments. But what you don't see in this file is any services. That's because sometimes people will do, well, they put the services all together, right? So this is horizontal. And then you'll see I have like configurations in config map. All my configurations are together. By the way, notice I put a secret in here. Don't do that, right? This is just for learning purposes. I have all my jobs together. Now, the other way you'll sometimes see it is kind of a vertical orientation where you say all of the resources related to a particular service go together. And I've done that here as well. Like if you look at my Elasticsearch, I've put the stateful set and the service together in one file. I did the same thing with the Mongo stack where I have the service and the stateful set together instead of separating them, right? So horizontal, vertical, it doesn't matter. It really just depends on what makes sense to you, how well you want to organize your code. And that's really all you need, right? Sometimes it can be informed by how you organize your files into different Git repos too. Like if you were to have your Kubernetes files alongside the application in its own Git repository, obviously that's the vertical approach because you can't put YAML definitions for other services in there, right? It's only in one repo. As on the other hand, if you keep all your files together in one location, like you have a repository with just infrastructure or DevOps type things, or stuff like that, then you can put those however you want. It's up to you. So whichever way you choose, just whatever makes sense to you and your team, right? But you probably want to come up with some kind of a pattern to organize things. So I've done a little bit of both just to demonstrate things. So let's start with the workloads. And let's begin at the beginning here. Just like I recommended to you, I recommended that you start with the UI service. And so I've done that first here. So I've created a deployment. And again, you really want to go straight to deployments. You really don't want to mess around with pods. There's no reason to create a pod explicitly, right? You're still creating pods, but do it with deployments. Even when you need one copy of something, use a deployment because it's just going to create the one copy, and then if it dies, it's going to replace it for you. So there's no reason not to use a deployment. And everybody I know who works with Kubernetes just goes straight to deployments, right? Now, the important things to point out here is our labels on our template, right? It's important that you guys get a good grip on the fact that your labels on your pods needs to match the selector on the services. And I think for the most part, people got this. I think you're in good shape there. Of course, there is always that thing where you copy and paste it when you do it on the next one and then forget to update it, kind of like what Abdul did. It's a normal thing that we do, but just make sure that you keep these in mind, that these have to match the service. And then under the spec here, there's really not anything special here. I have a single container. I have my name, my image. I have also added an image pull policy. You don't need that. I also have probes in here. You didn't have to put that, but later on, you could certainly add probes as you get things done. There's a trick in here, by the way, something that I haven't shown you yet, and that is that you can name ports inside these files. I can create a port called UI port, which is port 80, and then I can simply refer to that down here in my probes. That way I don't have to type 80 over and over again, right? So this one was really simple. There's no configurations, there's no environment variables, really, really simple. Now over in my services, I have my service for that one. And this one, the important points here is, first of all, it needs to be a node port. This is one of 2 services that must be publicly accessible, or in other words, they need to be accessible from the browser, from outside of the cluster. So this must be a node port. I have to choose a port number. In my case, I choose 30,080. And then of course the selector must match the label on the pods, which was app equals UI. That's pretty much it. That one's pretty straightforward. Over on my workloads again, let's go down to the next one. I chose to do the product API next, okay? The product API, again, it's just wash, rinse, repeat of everything that was in the UI deployment, and then I could tweak things. So I literally, when I wrote this originally, I copied all of this text, I pasted it below and made changes. I changed the name. I changed my labels, right? Got to make sure you do that. That's one that you're going to forget over and over again. I changed to product API. And then from there, things start to get a little bit different on this one, right? This one requires you to specify the environment variable and also to inject the file. And this one always trips people up, but it's an important thing for you to understand how to do. So I've defined a volume here, right? And this volume I've named products volume, and it is of type config map, and it refers to the config map named products config, right? So
Can I ask
over in my, yeah,
Oh.
go for it.
So the container's name that you have there, I noticed that it's different than the app name. Is it important that it's different than the app name?
In the app name, up here,
Yeah, like product API there, but down below you have RV store product API. Is it important for those?
yeah, they do not need to match. They're totally arbitrary as far as one another goes.
And
As
if they
long as
do,
your label has a corresponding service selector, that's what matters. And the
okay,
name of the container, just so you know, the reason that we have names on our containers is so that we can distinguish them inside of a pod. If you've got a pod with multiple containers, you need a way to like look at logs for a specific container in a pod. They don't have any functionality other than that.
okay.
Cool. Okay. Yeah, so pointing to my config map called products config, that one is over in my config map.yaml. And here's my products config right here. And this is the one that, of course, trips some people up. And I think it's good that you took the time to work through this because, you know, you work through a lot of the mental stuff. The first thing to point out here, and this one oftentimes bites people, they think that somehow they need to reference an actual file on the file system. And sometimes it's a difficult lesson to learn that you're actually copying the contents of the products.json that's over here in the RV store hackathon directory. You're actually copying this to your clipboard and then pasting its contents here, right? You're not making a pointer or a reference to a physical file on your machine. And you have to think about it, right? You're taking this information, you're sending it into your cluster as a config map. There is no tie back to your file, right? There's no way to have the cluster point back at your file and say, well, that's the config map contents. Now you got to like give it the contents. The other thing to point out is the file name needs to be correct. It has to be products.json. Sometimes people have product.json like that. And then also the indentation of the contents. It has to be 2 spaces indented from the key. If this was not indented like this, YAML thinks this is another key because it's at the same level, right? So it needs to be indented. YAML's very picky. We saw some of that during the hackathon where people had things that weren't working right. That's because the YAML is just very, very finicky about positional type things, stuff like that. Those spaces really matter here.
And one
Um,
other question, that pipe there, what's the,
Yeah.
I forget I remembered it needed to be there, but I don't remember its actual purpose other than.
Yeah, that's a YAML thing that just says that the value is a multi-line comment. So I could have absolutely put all of this YAML on one line, or excuse me, all of this JSON on one line right here without the pipe. Right here, it could have been like this, you know, products. Oh, I can't type products, right? And then like this, like I could have done the whole thing in one line. The pipe just says that what comes next is the multi-line value. That's all that is. That's not a Kubernetes thing. That's a YAML thing. Okay, so once
Is it,
you've,
sorry,
yeah,
is it okay to just mount the directory into the container like a volume? Like,
say again.
could you do that? Could you just mount the directory, like mount the file into a volume in the container?
Yeah, that's exactly what we do here. That's what we're doing. Unless I'm misunderstanding your question, that's what we're doing. We're saying, first of all, make the volume available in the pod. That's this section here. We're saying create a volume called products volume, and its data is going to be whatever is in that products config map. And then when we actually mount it down here to the container, right? This is my container called RV Store Product API. We are going to mount it. We're going to mount that volume to this location here /data/products in the container itself. So that way, when whatever application's running inside of the product API tries to read from that directory, it's going to see a file called products.json.
No,
Is that what you were asking?
I meant like, could you directly mount it, like mounting or something on your local host, like on your current?
No, you can't. And think about it this way, right? Mounting it directly to your local host makes no sense in the context of Kubernetes. But it might make sense on this little Docker desktop Kubernetes you have, which happens to live on your machine. But remember, we're putting things out on nodes that are running out in the cloud somewhere. There's going to be a server somewhere that's going to run your pod. It's going to have your container in it. And of course, your machine's not in that mix. It's not part of that equation, right? So you have to have over in your Kubernetes cluster the data needed to be able to create that file dynamically. Does that make sense?
Yeah. Yep.
Cool. Okay, so that gets the data in there, right? Once you have that done, now you can actually like exec into that container. You can look at this directory called /data/products, and you'll see in there a file called products.json, right? Oops. Like if I go in here and I do a kubectl exec IT, and I grab my pod here like this, and I do a -n RV store --bash, and I do cd data/products, and I do an ls right there. There is my products.json right there, right? Make that a little bit easier to see. So I'm actually in the container right now. I'm in the container and I can go to the file system and I can actually see a file called products.json, okay? Now the other side of this is we need to provide that environment variable. So there's an env here. Now you could have used a config map and put a key in there and with /data/products. In my example here, I just hard coded it. That's because there's really not a need necessarily to put this one in config map. I'm probably not going to use this elsewhere, but I totally could have, right? It just depends on whether or not the value is going to change, just from a best practices standpoint. You might ask, well, is this value going to change from one environment to another? And it's probably not, because this directory stays within this container, right? So could have used a config map, didn't have to. So I'm creating this environment variable explicitly called product file location with a value of /data/products. And I can see that in my pod. I'm in there right now. If I run an env, I can see there is a environment variable right there, product file location with /data/products. So the code, when a request comes in for products, it says, look up this environment variable from the operating system, and then look in that directory for a file called products.json. And of course, we put that there with a config map. So that's the two settings that we need to put there. Other than that, the rest of the stuff is pretty straightforward. We have a liveness probe, a readiness probe. I put /health in here, but you could put /products. That would be totally fine because you're not even aware that there's a health endpoint. And then for my service that goes along with my product API, for this one, now this is a cluster IP, which remember, if you leave out that type like that, it is the default. So I don't even have to explicitly put type equals cluster IP here. But make sure our product label is correct, that we're actually using the correct one. That leads to a lot of issues with people where they forget to change either the labels on the pods or the selector or both, and then they see really weird behavior, right? Like if I had two services, both pointing to the wrong set of labels of two different types of services, I could see really strange behavior because the service doesn't know what type of application is in the pods. It's just forwarding to whatever has that label.
Can I clarify something about the label and selector? There isn't anything special about the app key on that, right? Like you could have labeled it anything with any value, right? And then your selector would just have to match the key value.
Yep. I could use I could use application, I could use foo, I could use whatever I want.
As long
There's
as
absolutely
the
no
value
rules.
pair matches some label, right? Yeah.
Yeah,
Okay,
exactly. As
I
long
saw
as
app
the two
used
match.
everywhere, and I was using app, and I heard others talking about app, and I just was like, is there something special about app or no?
Yeah, that's just one of those things that grows a life of its own. A lot of people will use something like that app because it makes sense. It's the product API application. But no, there's annotations and labels. There's nothing about there's no rules here about what you use for the left or the right. It's your choice. I think there are probably a couple of rules, like it can't start with weird special characters and things like that. But for the most part, like any word that you might want to use is totally fine.
Is app called in the deployment file then? Like
so if you look at my deployment file, in my template section right there's my label,
app.
and I used app equals product API.
Okay.
And again, I could use something like application or service, right? I could say something like, well, the microservice is product API, but then I need to make sure that over here I have service is product API.
Got it.
But it's up to me.
Cool.
All right, and then that one's cluster IP. It's listening on 9001, right? Now the reason it's cluster IP, right, is that it's intended to only receive traffic through the API gateway, right? In fact, I kind of drew this for some people. Let me draw it again for those of you that didn't see it, just so that it makes sense, right? This one can cause a little bit of confusion for people. You're going to have your users out here, right? Here's our people. They're very happy, and they're sending their traffic from their browser down into our cluster, right? This is our cluster here, okay? And the traffic's going to come in, and well, let's kind of draw the full flow here. There's your service, right? This is our UI service. The UI service is going to forward to whatever pods it finds for the UI, right? Here's the UI. And then that information, request comes in for the UI, you put in the localhost 30,080 in the browser, the service forwards it to one of the pods, that sends it back and it loads in the browser. From there, the browser is making another request into our cluster. So this one is 30080. This one is the 30090, which this is the REST data. Okay, so the request comes in, and the request comes in, and it's going to hit the service for the gateway. And sorry for my horrible writing here, but that's a GW, the gateway. That is going to forward the request to whatever pods are for the gateway service. Okay. Now remember, the gateway service, its whole point is to evaluate the request as it comes in. Right? It flows in, and this is going to have some kind of a path like /products, /auth, whatever that might be. It looks at the request as it comes in from the browser and says, well, where should I send this request? So let's just say, for example, the first request comes in, hits the service, forwards to a gateway port, a pod, and then from there it says, well, this is destined for the product service. So it says, forward the request onto the product service. Now, the product service, of course, is going to forward to one of the product pods. You're going to have one or more. Here's our product pods. And that ultimately is what's going to grab that products.json from the file system inside of there, send it back to the user, which is going to populate things on the browser, right? And if it's something like, the order service, right, it's going to go down here to the order service, which is going to forward to one of the order pods. This is O. And in that example, this one is actually pushing and pulling from the database, which is going to say, well, send the traffic to the Mongo service, which is going to forward to the Mongo pod. So it's important for you to understand that each one of these groupings of service and pods collectively is the microservice. If we look at the where is it? There it is. If we look at the diagram, I've kind of abstracted that a little bit, where each one of these circles represents the microservice in its entirety. It's the service, the Kubernetes service, and the pods that are actually going to serve that. So there is, sort of something kind of like this, where this becomes the microservice, right? So hopefully that makes it a little bit more clear and will help you to better track and trace traffic as it flows through it. It seems like a lot. It seems like a lot of steps, right? But it's really not that bad. You just have to understand that at every single level, every single one of these microservices, we need a service because that acts as the internal load balancer to whatever pods, right? You may have 1, 2, 10, 500 pods under here, under this order service. And when the gateway needs to forward to the order service, we want to make sure that that traffic flows to one of those healthy pods, okay? So hopefully that helps clear some of that up, because I know there's probably a little bit of confusion there about that. All right, so the rest of this is pretty much, in terms of our workloads and our services, the rest is just wash, rinse, repeat, right? We have an auth service. The only real thing to point out here, one, is that, actually there's not much to point out here. Of course, the labels have to be changed. There's no environment variables or config maps needed here. The order API, this one only needs one environment variable. So I have an environment from an env from line here, which pulls from workload config. This is a config map. So I have a config map here called workload config. It has that Spring profiles active with a value of compose on it. We've got our API gateway, which this one doesn't need any environment variables. Actually, I do have one in the solution, but that's a holdover from when this used to be written in Java. So even though it sets it here, it's not actually used. The slide deck doesn't tell you to put an environment variable on it. We have our services, right? They're all just a collection of cluster IP services, right? And the reason they're cluster IP, again, is that we want our traffic to come in through the gateway at all times. We should never have traffic come directly to the order database, the order service, for example, or directly to the product service. Yes, you do it for testing purposes. You use things like port forwarding to test it out. But when it's all said and done, when this application is actually being used, we want all traffic to flow through that gateway as the centerpiece, as the single entry point to our API. That's why this one, this one, this one are all cluster IP, whereas these two, the UI and the gateway, those are node port, because those are the only two ways to get traffic into the cluster, into the application. So yeah, it's just a bunch of services of various configurations. I put everything into a namespace. So here's an example of how a namespace is created. I called mine RV store. And then of course, all of my various files just have in the metadata a namespace, which is RV store. Let's look at the Mongo just a little bit. Mongo, there's nothing terribly important here or terribly special about the Mongo service. I have a stateful set and I have a service. My stateful set, the only thing really to point out about a stateful set at this point, of course, we walked through all the features of a stateful set, or at least the main concepts. The only real difference at its most basic between a deployment and a stateful set in terms of syntax is that you have to have a service name here. So that's a required field. If you tried the stateful set, you may have gotten an error saying service name is required. Other than that, it's pretty straightforward. This one has an environment, a pair of environment variables. They come from, in this case, a secret, not a config map. And that secret is up here in the configuration files, which, one more time, this is not something you would do in a real world situation. You'd never have a secret sitting alongside everything else. It's only here for the purposes of the hackathon. But it's going to grab these two values and set them inside the Mongo. And then the other thing I'll point out here is there are some lines here that are commented. I've done a volume and a volume mount, and they are currently commented out. And the reason they're commented is that these point to a location on my workstation's hard drive. You do not have that hard drive location on your machine. So if you tried to do this with these uncommented, your pods wouldn't actually bind. They would actually fail to start up because the volume itself couldn't bind to the file system location. So if you do want to try it, if you want to try mounting a volume so that your Mongo data, so your order data stays in place in between pod removals, you can go to the storage YAML, and you'll see an example here of a storage class, a persistent volume, and a persistent volume claim. Remember when I said volumes were yucky and gross? Here's why. You look at this and there's a lot of grossness. But right here for the persistent volume is the type. It is a local volume, which we call local and host path. Both use the hard drive of the host machine. And I have a path here. So there's a directory on my machine called rvstore with data. You could just change this to a valid location on your machine. Then when you uncomment out these lines, now your data, you will see that your Mongo stores its data on that location in your machine. Now you could terminate the pod, you could delete it, it would get recreated by the stateful set, and you would see that all your orders are still there because they are externalized. They're out of the pod, out of the container, and they're somewhere external to the cluster. The Elasticsearch, just like Mongo, pretty straightforward. This one, I don't even have a volume set up for this one, but you just have to make sure you have all the environment variables that were specified in the slide deck. Other than that, it just kind of works. And then jobs. We have two jobs in here, the order simulator and the Python product synchronization service, right? So the order simulator, this is just a cron job. I have it set up to run once a minute. And the only real thing to point out here is it's got a template section. Don't worry about this annotation, by the way, the linkerd.io/inject. That has nothing to do with this class. This is something that I added in there. I've been messing around with Linkerd, which is a service mesh on here. This just tells Linkerd to ignore this particular pod when it gets created. So that's what that is. So I even say in here, ignore this if you didn't learn about Linkerd. But we got a normal container here with an environment variable with that workload config. That one is required. And then I've also added an environment variable explicitly, job equals true. So this is actually a combination that one comes from the config map, one is explicitly defined on there. You can do that, you have flexibility. And then kind of the same thing here with the product sync service. It runs once a minute. I have one environment variable, which is job equals true. And so if I look at all of this over here on the right side of my screen, you can see I've got all these pods. You can see my jobs running and they're in completed status. Other than that, it has all the qualities, the deployments, the replica sets, all this kind of stuff. At this point, this is highly resilient. If one of my applications starts to misbehave because I have probes on it, it will be fixed, right? And if one of them dies and crashes and burns, it will be replaced because they're part of replica sets, because they're part of deployments. I think that just about covers it. I can't think of anything else that I need to explain here. Did I catch all the files? Yeah, I did. Any questions?
How to tell what are the values in the config map that needs to be wrapped in the double quotes or what are not?
What are the values that need to be in the config? I missed the last part of that.
So you see the value. If the value is true, you need to wrap it as in the double quotes, or if it's like a star.
Oh, yeah. So I've got like my job here where you have this in quotes. Yeah. So YAML is a little bit picky about numbers and things like that. An environment variable has to be a string in an operating system. That's the only data type there is. But YAML will actually interpret a true as an actual Boolean, right? You'll notice that is blue, but never down here. And job are in this like orangey, yellow, reddy color. I'm colorblind. Because YAML actually recognizes this as a Boolean. Just like if I do a number, you notice it's a different color. And so because an environment variable has to be a string, it will complain to you and say, hey, true is not a valid, value to put in there. And so that's where the quotes come from. It just makes sure that this is a string. So this is just one of those corner case type things that you don't oftentimes run into.
Okay.
Makes sense.
Yeah.
Cool. Yeah, the same thing up here. Like if you look at the schedule, you'll notice it's in quotes. That's because this is a really screwy looking string. And if I don't include that, then yeah, I even get errors here basically saying, hey, this is not valid YAML. It's a weird data type or something. So you put the quotes around it and it says, yeah, that's a string. Okay, so in terms of kind of some final parting thoughts here, guys, here we are with the last few minutes of the class. I already mentioned to you, right? It's very, very important that you solidify this stuff. No matter how much you paid attention in this class, and no matter how comfortable you felt with this hackathon, at this point, this is not like riding a bike, right? You're still on day one of learning how to ride that bicycle. And just like with riding a bike, if you did one day of it, and then you came back a year later and tried to ride that bike again, you might as well start over again because basically you've forgotten any of that muscle memory. Well, this is the same deal. Kubernetes has such a steep learning curve, and there's so many weird concepts and abstract ideas in it that at this point, if you were to drop it right now and not come back to it for 6 months, you would lose it. I can tell you this from personal experience. When I first learned Kubernetes, I did that. I started learning it. I did some online, stuff where I learned how it worked, and I kind of had a little bit of a grip on it, but I was feeling pretty good. And then life, being life, it got in the way, and I had other priorities. It was one of those things. I was trying to learn it on my own time, and then I got busy with other stuff and dropped it for a while. And you know how that is. You drop it, you don't have a real world thing to work on, so you don't come back to it for 6 months. And when I came back 6 months later, yeah, sure enough, it was all gone. It was all toast. And so I had to start over. Basically, almost nothing was retained at that point. Of course, I didn't have the benefit of doing an actual course like this, so I probably would have been in a little bit better shape. But I was learning it on my own. And so unless you're using it on a regular basis at work, or you have a pet project that you're doing or something like that, you're going to lose it. I guarantee it. So I highly suggest, like I said, do this hackathon again once, even better 2 times over the next few months. Or if you're working with Kubernetes on a regular basis at work, you're in pretty good shape. Also, continue to read up on this stuff. Continue your learning, right? Pluralsight is a great resource for stuff like this. If you go on Pluralsight, you will find a lot of courses on more advanced topics in Kubernetes. Things like ingresses, Helm, service meshes with Linkerd, Istio, operators. Like there's so many more things. And by learning some of those things, you are going to be reinforcing the fundamentals. And they will make more sense now because Linkerd and Istio and things like that, what do? They just use the constructs and the abstractions that we talked about this week. So you're going to be reinforcing it. That's a great way to go if you just want to keep your learning up. But short of that, I would start, follow people on Twitter, set a Google News alert, things like that. Like I have my Google News set up to always show me things related to cloud and containers and Kubernetes and stuff like that. So I'll just be like sitting around, I'm on my phone, just kind of relaxing for a little bit, checking to see what's going on in the world. And oh, there's an article about some topic in Kubernetes, and I'll just skim through it a little bit. And yeah, okay, most of it makes sense, most of it I know. But oh, look at that, there's something. Maybe there's something I don't know about, but I can immediately recognize that it's using all of the fundamental concepts, and it just engages that part of your brain, which is going to make you remember those concepts. So the takeaway here is just keep getting regular little sips of knowledge and refresher on things to keep you sharp. Otherwise, you will learn it, right? Use it or lose it. It's like a muscle. Use it or lose it. Okay.
Can I ask one last question?
You betcha.
So I was curious, like I kept looking around for the authorization API. Like it doesn't really, it's not clear how that actually passes a JWT, I think is what it's called. How it passes it back to the UI. Is that happening behind the scenes in the image? Like I was kind of curious how that connection actually happens. And like when I went to the UI, I was having problems with the UI. Like when I clicked on the link where it's supposed to say test the auth service, it wasn't actually working properly. And I was curious, like, I couldn't quite figure out why that wasn't actually working properly.
Got it. Okay.
So I didn't ask about it, but
yeah, that's okay. So just to kind of show that to you, like I've opened up the dev tools. Say again.
Yeah, sorry, you're there.
Okay, yeah. So I opened up the dev tools, and this allows us, if we go to the network tab, to be able to see the actual HTTP calls going on behind the scenes. So if I hit login, you see that I get a call here, and I can actually see it's hitting localhost 30,090/auth/login, right? So what happened there is the traffic came in on 30,090, hit the gateway service. The gateway service forwarded to one of the gateway pods, which forwarded me to not to the product service, but to the auth service, which forwarded to the one of the auth service pods, right? Now that one, at that point, if this was a real one, it would have checked your username and password and whatever. It would have checked it in the database and determined, are you a valid user? And then it would generate a JWT, which is a token, which just looks like this, right here. Here, let me get the response from here. Maybe this is a little bit better. And so it returns back a JSON payload. And let me actually go here and I'll show you what one of these looks like.
Yeah, mine
hard to grab.
Aired out there. So
it did. Okay. And so that means that there's something wrong with your auth service. This one, because there's like virtually no functionality within the auth service, if that didn't work, then that means that most likely there's a problem between your gateway when it hits here and this connection to your auth service, or a problem with your auth service itself, where maybe like your labels were off or something like that. So you have to make sure that each one of these connections is correct, right? The label and the selector, but you also have to make sure, oh, and by the way, I forgot to point this one out. A bunch of people ran into this. The gateway service is going to forward to the pod, and then the pod is going to forward to the downstream service. This is always a source of people helping them to understand what's going on. The gateway service forwards the request to this by name. We can actually see this concretely if we look in the microservices directory, and I open up gateway service, and then I go to my Kraken D. You can actually see this. This might help you understand it. So Kraken D, this is that API gateway. When traffic comes in and hits the /products endpoint, what it does is it forwards to this address on this path. So it's actually forwarding to this name right here. And several of you asked me about this and ran into this. It forwards to rvstore-product-API. And we can see down here, like here's the order API endpoint, and we have one for the auth API endpoint, and here's Elasticsearch. These names, this is what the name of those services is. So back to the drawing here, this one, this product service has to be named rvstore-product-API, because when you create a service, a Kubernetes service, its name gets registered in DNS. So this, by naming that, that's how we can enable pod to service communication around our cluster, right? Things like this, right? The Mongo service, that Mongo service had a specific name, and the order service pods call that in the connection string for Mongo, right? I can see in here, like if I look in my order API and I go in here, there is in here a there's a properties file, an application compose file. Right here, this is the connection string to the Mongo database. Look, the name of it is right there. So this is how we enable that service to service communication, right? The DNS within Kubernetes that enables that stuff.
Got it. Yeah, I think actually that was my problem.
So you might have been seeing a failure at multiple levels there, where you may have had something breaking here, or something breaking here, or something breaking here. And this is why I like this lab, because it gives you a chance to systematically take it step by step and break things down. Whereas, when you're new to Kubernetes, like you just have a pile of resources, and you have no way to know how to pick your way through the pile, right? The goal here was to get you to understand that you work your way through the flow, systematically finding out what the problems are.
Yeah, I was able to look at the individual ports, but if I tried to go through the UI, I was having some errors
Yeah.
there.
Yeah, most likely. I'm willing to bet this was your breakage right here. So I would go back and check to make sure that when the gateway service is trying to forward your request to your auth service, that the auth service has the right name. By the way, these hints were in the slide deck. I gave them to you backwards, and I did that on purpose because I really, really, really wanted to make this point painful so that it would drive it home. Like if you look in the let's say the authentication API, for example, nowhere in here do I tell you, hey, make sure you call it rvstore-auth-API, right? I don't give you the name of the service. But if you look in the gateway service,
yeah, it's in the gateway. I
it's
created
right
with my
here.
own names actually, and ended up like, oh, why it's
Everybody
not working?
does. Everybody does, and that's totally normal. I wanted you to name them wrong so that you would learn this lesson. If it just worked, you'd never even know that that was
Yeah.
a thing, right?
And
And so I
yeah.
gave it to you backwards to force you to do that.
Yeah, I think I had a dash between RV and store. And that was why I was changing it.
This is great.
Yeah.
Thanks much.
Cool. Any other questions about this stuff?